Alrighty, so I chose my project to do it on is RAD-140, which is a selective androgen receptor modulator, also known as SORM. And let's begin. Alright, this project, this paper was published by Clinical Cancer Research, October 3rd, 2017. And yeah, that's the big kind of light intro. SORMs is super interesting. Basically, it's a group of drugs that can bind to androgen receptors that is going to not create quite as harsh as side effects as certain other drugs like testosterone can or estrogen. Like if you have an influx of those, like it comes with side effects. While SORMs, on the other hand, they're a lot lighter in side effects, and they can also maybe not be but they're also not as potent because they don't their binding affinity and what they do is not quite as harsh. All right. So in this study, they basically they designed both an in vivo and in vitro assays were used to determine the affinity of RAD to 4 nuclear receptors, and they evaluated the tissue selectively by the AR activity, and they also did ER, also breast cancer. Yeah, right here, models, correct. All right, and then just as an overview, um, the most common expressed hormone receptor in breast cancer with 75 to 90% is ER plus, and approximately 30% is ER minus. Alrighty, so that's the kind of overview what they're trying to do. Now, transitional relevance right here is pretty important. And this kind of goes to the expression of both ER and AR positive breast cancer has been well described. Androgens inhibit the proliferation. Androgens inhibit the proliferation of ER and AR positive breast cancer cells. So that would be like RAD or another SORM. It could be like LGD, Ostarine. That's just to name a few of other SORMs that they have out there. But RAD specifically, in its chemistry, is made to bind to these grouping of receptors, and it's actually shown to prevent muscle wasting disease and also increase lean body mass and strength. So RAD's pretty awesome, pretty cool drug. All right, and then kind of moving on to what's kind of important is these things right here. Let me go to my notes right quick. Not too far. All right, so what they're kind of talking about is they kind of show in this kind of first part is RAD binding to is binding affinity basically to DHT, estradiol, progesterone, and diaxethone. So it's those 4 things, and it's showing that RAD's binding affinity. So the first one kind of shows is a sigmoidal curve, similar to DHT, not quite as strong. Concentration of estradiol, non-existent, and then concentration of diaxethone, non-existent, and then a progesterone. It did have some binding affinity similar to it, but progesterone outcompeted it in the ER things. But it was very similar to DHT in its strength. But the thing is, DHT comes with a lot of negative side effects that can come with it because it doesn't selectively bind. It just binds in high amounts. While RAD, on the other hand, it has a similar potency of binding, but just without quite as harsh of side effects. Cool. All right. So yeah, as a whole, what I'm kind of like trying to say is that RAD is pretty much it's a pretty potent selective androgen agonist. These SARMs are selective AR ligands that have been shown to act as agonist or antagonist in a tissue context, depending on the matter. And that's the cool thing about SARMs is they can be an agonist or an antagonist, which is pretty cool. On to B. B was showing that it was a breast cancer and a prostate cancer right there. So this is the breast cancer, this is the prostate cancer. And it was just kind of just showing you the DHT to RAD and its, you know, the activity. And then C right here, ethanol was used as the vehicle. And it was just showing that the expression of everything, while D was, these cells were, you know, these cells were in steroid depleted condition and then treated with either RAD or DHT, and then were dyed with trypan blue, sorry about that, before they were subjected to living cell count by a Nexcellicom cellometer. And then this was shown a p-value that was, oh yeah, it's right here, shown a p-value of 0.05, which is significant, which is pretty cool. All right, cool. 1 second. Lost my page. All right, cool. And then scrolling down a little bit, pharmacodynamic analysis reveals that RAD mediated regulation of these right here and this gene. It has been proposed that androgens suppress the ER signaling in this, which may contribute to the proliferation activity. But the cool thing about RAD is that just because it is binding to this guy pretty hard doesn't necessarily mean that it's going to suppress ER signaling because of its selectively binding affinity, while DHT on the other hand will affect its signaling, and which may contribute to, you know, anti-proliferation activity. But RAD on the other hand can prevent that. So yeah, it's better to understand the mechanisms of action of the SARM in these breast cancer models, and basically were examined by pharmacodynamic changes, where they focus on these two right here in this model. And a profound induction of AR target genes, including these guys right here, was seen in RAD-treated tumors. While the expression of AR gene was not affected, fulvestrant, as expected, did not induce the expression of these AR target genes, although slight increase in ER message was sent. The ER target genes, these guys right here, were found to be substantially suppressed in RAD-related tumor levels to the comparable or even lower seen in lower than seen. Okay, cool. So that kind of just backs up kind of what I said right here, is that RAD itself has been shown to, like I said, not necessarily affect these guys quite as hard. I'm sorry, less than this actual fulvestrant drug does. And this is a legit breast cancer drug. And not only is RAD do all this stuff, but it's also shown to prevent muscle wasting. It's shown to, you pretty much you'll gain strength from it, and you'll probably you basically retain more lean body mass. And kind of my hope of what they do after this study is maybe they kind of give some more light in the direction of SARMs, and maybe they can start looking at using SARMs for treating other things, and maybe even like, manipulating certain formulas and trying to make them even better, for treating, and coming up with ways to treat certain drugs and diseases, which is pretty cool. And this is kind of like everything I was saying right here. This is just in the graph form of treating this. Okay, 1 second. All right, so this is kind of just showing these AR/ER pathways of the genes that I mentioned before, which was ESR1, and these were treated with RAD. These are breast cancer xenografts right here in ABC, and this is just signaling pathway, and this right here is kind of just showing. Oh, cool! And this is a list of upregulation and downregulated genes that SARM this SARM's treated. It's pretty cool. Yeah. So yeah, enhanced anti-tumor activity can combine with administration of RAD and this inhibitor. Pretty cool. Pretty cool stuff. I was pretty pumped about this paper. And then this study right here, I kind of want to hop to the discussion because this is super important, and something that I think is pretty interesting is for the first time this study has actually shown that RAD-140, an orally available SARM, as a research chemical that you can pretty much find anywhere. Like you can just Google it and like you can pretty much find, stuff on it. Is an AR agonist in breast cancer cells, and suppresses the growth of proliferation of multiple AR/ER breast cancer cell line and xenograft models. It's pretty cool. So hopefully this can open up more discussion into SARMs and maybe fund more things, and maybe this can be taken in with other chemotherapy methods to help prevent muscle wasting and also anti-tumor activity in certain things like the breast and also in prostate. So yeah, the RAD treatment was found to decrease the expression of DNA replication related genes in breast cancer cells, consistent with the previous report that these genes were suppressed in androgen-treated prostate cancer cells. Pretty cool. Combined administration with RAD and this inhibitor right here, this guy, was more, yeah. So yeah, like I said, just maybe taking this along with another inhibitor or with something else can even, tenfold this and make it to where like, no tumor growth at all can come from that. Yep. Second. All right, and then just as my closing thoughts is basically that maybe from these studies that it can kind of help shed some light on SARMs, because I know in recent news SARMs have gotten like a rap from athletes, I think, taking them to improve cardiovascular endurance and do things, which they can do all those things, but also there is definitely a scientific and clinical side that can be administered and looked at and developed with SARMs and the whole family that comes with it, because there's a lot of SARMs out there and a lot of different methods of action that can be studied and should be studied. That's pretty much it. Thanks.